Here there is another question. Show that the relation R in the set A is equal to 0 to 12, the integers given. And the relation is defined as A comma B belongs to R if modulus of A minus B is a multiple of 4. This is to be proved as an equivalence relation. And then there is another sub-question, find the equivalence class of 1. So let's, if you want to try it on your own, you may please try, pause the video and then come back and watch. First thing is, we always talk about the given set. The given set is A, which is 0 to 12, the integers. And then I write what the relation means to me. The relation is A comma B belongs to R. A is related to B, or A comma B belongs to R. These are all single elements in the set, right? So I pick up two elements from there, A and B, and then I say A is related to B. A comma B belongs to R. If implies modulus of A minus B is a multiple of 4. So an element A is related to B means modulus of A minus B is a multiple of 4. We need to prove that this is an equivalence relation. And if you want to prove that it is an equivalence relation, first I need to prove that it is reflexive. And to prove reflexivity, I just need to pick up one element. So I'm going to just pick up one element A from the given set. So I'll say for every element A taken from the given set, I need to prove that A is related to itself. That means A comma A belongs to R. So I'm going to make that statement first. I'll say A comma A belongs to R. So I wrote that A is related to itself. But I need to justify it. Now how do I justify? Modulus of A minus A is 0, which is definitely a multiple of 4. Therefore, the statement which I made there is justified. Modulus of A minus A is 0, therefore A is related to itself. A is related to it. Therefore, R is reflexive. Now I need to prove the symmetry. And to prove symmetry, we need to pick up two elements from the given set. So I'm going to pick up two elements here. I'll say for every A and B taken from A, it's conditional. So I will assume one pair, that is ordered pair A comma B belongs to R. A is related to B. A comma B belongs to R. I should prove then B is related to A, that is B comma A belongs to R. So I start with the assumed result that A is related to B. What does that mean? Modulus of A minus B is a multiple of 4. But if modulus of A minus B is multiple of 4, modulus of B minus A is also a multiple of 4, because there is no difference between modulus of A minus B and modulus of B minus A. That means B comma A belongs to R. B is related to A. So when A is related to B, we could prove that B is also related to A, the other way around. And therefore, R is symmetric. So we proved symmetry. Now we have the transitivity left. I need three elements to be picked up. So I say let for every A, B and C taken from the given set A, we assume two pairs. We will say A is related to B and then B is related to C. A is related to B and that B is related to C. Now I should prove that A is then directly related to C, which is the transitive property, which means using these two results, I should prove that A comma C belongs to R. So we have this assumption, we continue working on that. A comma B belongs to R implies that modulus of A minus B is a multiple of 4. Similarly, now B comma C belongs to R implies modulus of B minus C is a multiple of 4. Now I have slight difficulty in adding up these two because both are in modulus. So what I am planning to do is, if the modulus of a number is a multiple of 4, the number itself has to be multiple of 4, because by taking the modulus we only make negative quantities into positive. An odd number will never turn out to be an even number. A number which is not divisible by 4 is now not going to be a multiple of 4 if I take the modulus. So if the modulus of a number is a multiple of 4, obviously the number without the modulus should also be a multiple of 4. So I'm saying a minus b is a multiple of 4. If modulus of b minus c is a multiple of 4, also the number itself is a multiple of 4. So I can now say a minus b is some 4m, where m is an integer, and b minus c is 4n, where n is also an integer. M and n belongs to z. So I can add them up now. So I'm going to add these two relations. So I get a minus b plus b minus c is equal to 4m plus 4n. Plus b minus b cancel, so I am left with only a minus e on the left side. 4 is common factor. M and n are integers, so m plus n is an integer. So 4 times an integer makes a minus e as a multiple of 4. And if a minus e is a multiple of 4, we say a comma c belongs to R. A is related to c, or a comma c belongs to R. So we started with a is related to b and b is related to c. Now that implies a is directly related to c, which makes it transitive. So R is transitive. And so now R becomes an equivalence relation because it is reflexive, symmetric, and transitive, which makes it an equivalence relation. Now for the equivalence class of 1, what is the meaning of equivalence class of 1? Our given set was A, which had integers from 0 to 12. Equivalence class of 1 means the set of all the elements from the set which are related to 1. So we try to write the set of all the elements which are related to 1. And this is how you write equivalence class. When you write, you can find there are 3 elements which are related to 1. Now, how do we justify that? 1 is related to 1 because modulus of 1 minus 1 is 0, which is a multiple of 4. 5 is related to 1 because modulus of 5 minus 1 is 4, which is 4, a multiple of 4. Then 9 is related to 1 because modulus of 9 minus 1 is 8, which is a multiple of 4. So that's the equivalence class. And now I have a question for you. Show that the relation R in the set n cross n defined by a comma b related to c comma d if and only if a square plus d square is equal to b square plus c square for every a, b, c, d taken from n is an equivalence relation. So the given basic set is n cross n. You pick up 2 elements from there, a comma b and c comma d, and they are related if and only if. Can we get this in words, this relation? Sum of the squares of the extremes is equal to sum of the squares of the means. It's not just the means, it's the sum of the squares, individual squares of b and c. So sum of the squares of the extremes, a square plus b square, is equal to sum of the squares of the means, b square plus c square. We need to prove this as an equivalence relation. You try. Good luck. Pause the video, watch it, copy down the question and complete it.